This video is of the quiz review for our graphing trig unit. If you want to use these properties on the side, you can do that. If you would rather just show your work, you can do that. I'm going to give myself a little bit more space. So A for amplitude, the maximum y value minus the minimum y value divided by 2. So minus a negative is adding. A half plus a half is 1. So our amplitude is a half. I like to do midline next. Maximum y value plus minimum y value divided by 2. And the period, and here's the maximum. We get back to the maximum in pi. So the b value is 2 pi divided by pi, which is 2. I can pick whether I write sine or cosine, and for this graph, I'm going to choose, I'll do both because it's a review. So to start, I'm going to choose cosine because the maximum is on the y-axis. So this would be the c value for cosine. So I got y equals amplitude, b value, c. You can leave out these zeros. It would look a lot cleaner as 1/2 cosine 2x. If you were going to choose sine, all the other pieces are the same except for the c value. And the sine pattern is, this one's easiest. Midline going towards maximum. I wouldn't pick this unless I had to because it's not labeled. But for our review purposes, this point is 1/2 of pi over 2. That means this is the negative side. So moving to the left, pi over 4. So that would be the c value for sine. All right, for number 2, the maximum's at 3, and the minimum's at -3. All right, the period for this one is, see how this starts on the midline, and we get back to the midline here. That looks like pi over 2. So the b value is 2 pi divided by pi over 2. And when you divide by a fraction, that's the same thing as multiplying by the reciprocal of the denominator. So this gives me 4 pi over pi, which equals 4. Okay, so this graph is easier to use sine since our pattern starts at 0 with the midline going towards the maximum. Oh, I don't need to write +0. I could do cosine if I find this maximum point, so I could do 1/2 of pi over 4. And shift the graph to the right, pi over 8. All right, for number 3, we've got the highest y value at 2 here, and the lowest y value is -4. So amplitude maximum minus minimum divided by 2. The midline, maximum plus minimum y values divided by 2. The period. I'm going to sketch my midline real quick. And we'll make it easier to visualize. All right. Oh, except that's all over my X scale. Hang on. All right, so there's the midline. I can see that the graph starts on the y-axis on the midline. So the period would be here. Oh, that's not labeled. Okay, so let's make it a little easier. If this says pi over 2, that means this is pi over 4, which means this is negative pi over 4, pi over 2. So then this is 3 pi over 4. So then this is 5 pi over 4. No, it's not. I made a mistake. I can't. All right, I'm counting this wrong. Let's fix this. Come on, Miss Weiss. All right, let's try again. 1 over 4, 2 over 4, 3 over 4. So then this point is pi. Maybe that says that under there because that's going to be 4 over 4. Oh my goodness. So the period's pi. I don't know why I made that way more difficult than it had to be. Let's see if that's really under there. The graph's right over it. You can't really tell. All right. I don't feel so bad now. All right, so the period's pi. Way better than that fraction I thought it was going to be. Which means the b value is 2 pi divided by pi, which is 2. I'm going to pick sine again since our graph starts on the midline on the y-axis and goes towards the maximum. So y equals amplitude, sine, b value, no horizontal shift, -1. If you really want to do cosine, this maximum is half of pi over 2, which is pi over 4. So we go to the right, pi over 4. All right, our parent functions. Sine and cosine, we've been doing more than a lot. All the critical values, that means the quadrantals, 2 pi, pi over 2, 3 pi over 2, and oh wait, I need an amplitude for the parent function. All right, sine is midline, maximum, midline, minimum, midline. When you connect your points, a nice smooth wave, arrows on the end. Let me set up my critical values again. Amplitude. All right, cosine starts on the maximum, midline, minimum, midline, maximum. And because sine and cosine are bounded both above and below, you can't continue your graph higher than this maximum of 1 or minimum of -1. So make sure to turn your graph around at these endpoints so it's clear that the range is bounded between those two values. All right, tangent. So tangent is undefined at every pi over 2 value. So I'm going to draw dashed lines or dotted lines at negative pi over 2, pi over 2, 3 pi over 2. And then I remember which way the graph is increasing. If you're not sure, you don't remember, you could always think about the value of tangent pi over 4, which is positive 1. So at pi over 4, we've got positive 1. Here's my 0. Tangent of negative pi over 4 is negative 1 because that's in quadrant 4. So now I can see that my tangent graph would increase going towards the asymptote. I find it easier to graph in 2 parts like this. And there's our tangent graph. For all the reciprocals, so cosecant, it's nice to build off of the sine graph. And everywhere that the sine function had an x-intercept is where cosecant will have an asymptote. And for the curves, I'm still going to need my 1 and negative 1. The pieces of the wave reflect up and go towards these asymptotes. For the secant graph, I'm going to build that off of my cosine graph. So anywhere cosine has an x-intercept, secant will have a vertical asymptote. Still need the maximum and minimums here. So then the secant waves, also here. Let's graph this asymptote. So the pieces then of the secant waves are going to build out towards these asymptotes as well. And then for cotangent, anywhere tangent has an x-intercept becomes an asymptote. And then I'm going to go back to this pi over 4 value, that cotangent of pi over 4, since that pi over 4 is in quadrant 1, has an output of 1. So here at pi over 4, I get my value, my y value of 1. This is at 0. So the cotangent curve is actually decreasing. So this curve is then decreasing in between each asymptote. All right, now we're going to make the graph. You can list out these properties if you want. You don't have to. If that's helpful to you, do that. So A is the value of 2. Amplitude is always positive. So the amplitude is also 2. Here the B value is 1, because there's a 1 here, which means the period is 2 pi divided by 1. There is no C value, and the D value is at negative 3. And I always start with my Y scale. So our midline is at negative 3. From the midline, I count up my amplitude and down the amplitude to get the maximum and minimum Y values. Since the period is 2 pi and there's no shift, I'm going to put my quadrantals. And it's a cosine, so that's maximum, midline, minimum, midline, maximum. And make sure you turn your points around at the endpoint. I'm sorry, turn your curve around at those endpoints. All right, for 6, the A value here is actually -1, but the amplitude is 1. This negative means there's a reflection. So I'm going to write that so I don't forget to actually reflect the graph. B value is 1, which means the period is 2 pi. I actually have a C value now. That's to the left, pi over 2, and there's no midline change. So our starting X value is negative pi over 2. To find the endpoint, I take my starting value and I add the period. All right, well, we need a common denominator. So this is negative pi over 2 plus 4 pi over 2. That gets me 3 pi over 2. Then I need the middle. So I need a middle point. That's 1/2. Add the endpoint. These 2's divide or these 2's divide, doesn't matter which way you want to simplify that, and we get pi over 2 is the middle. And then this works out actually really nicely because the middle of negative pi over 2 and pi over 2 is 0. And then the middle of pi over 2 and 3 pi over 2 is pi, because that's our quadrantals. If you want to calculate this, you can. 1/2, add up the endpoint. And then from here, that's 1/2 of 4 pi over 2, which is 4 pi over 4, and that's how I get this value of pi. So now for our graph, it's sign reflected. So midline, minimum, midline, maximum, midline. Put arrows on the end. All right, last but not least. And A value is -2. Amplitude is always positive. There's a reflection. B is 1. The period, that means it's 2 pi. I had to pause my recording. I was interrupted. Now I forget what I was saying. So let me just pick back up where we started, or we left off. So the period is 2 pi. Cosine, no C value. And this one has an amplitude of, I'm sorry, a midline moved up 3. So up 2 from there, down 2, no period change. Put a dashed line for my midline. All right, so now we've got a reflected cosine, which means we start at the minimum, midline, maximum, midline, minimum. Turn it around at the endpoint. Arrows on the end. So as I'm graphing these 3, I realize there's no period change to practice. So let's practice one. Let's graph y equals 2 sine 16x. All right, so our amplitude is 2. Our B value is 16, which means the period is 2 pi over 16, which reduces to pi over 8. So what this means is we would get 16 waves in the space we normally would have 1. And then the D value is -4. All right. So from my midline, I'm going to count up 2 and down 2. That's a bad scale. Okay, down 2. With a period change of pi over 8, I'm going to make pi over 8 the ending value on my x-axis. Then I have to go halfway because I need 5 equally spaced points. So half of pi over 8 is pi over 16. Then I have to have another halfway point. I need halfway here. So I'm going to do half of pi over 16, which is pi over 32. Then I'm going to count this out so I don't have to find this midpoint. This is 1 over 32. This is 2 over 32. That would reduce to 1/16. So this is 3 over 32, and this would be 4 over 32, which reduces to 1 over 8. Obviously with pi's, but I'm not going to count it with the pi's. So this point is 3 pi over 32. Sign not reflected, so midpoint, maximum, midpoint, minimum, midpoint. And put arrows on the end.